A very good morning to Dr. Noni. I'm Wen-Yi. Today I am presenting about the detailed design of major equipment for the ammonium sulfate and methanol production plant from flue gas. The major equipment that I designed is distillation column. The agenda for this presentation includes introduction, design methodology, specification sheet, equipment drawing, and cost estimation of distillation column C105. The objective of this column is to separate the pure methanol from the mixture of methanol and water. Methanol will flow up to the column and known as top product, while water will flow down to the bottom of the column and known as bottom product. The column internal to design this column is tray column. It is a type of distillation column that is widely used in industry. It uses tray to contact both liquid and vapor, but the separation will be occur above the tray. Besides, tray column is more robust compared to pack column. It can withstand high range of liquid and vapor flow. However, it is more efficient for high pressure drop process that will lead to flooding. Therefore, the control system of the flow transmitter in this column should be well designed to prevent the column from flooding. For the operating condition, feed that consists of mixture of water and methanol enter the column at 327 kPa and 25 degrees Celsius with a flow rate of 54,279 kg per hour. The product, methanol, has a temperature of 40 degrees Celsius and pressure of 100 kPa, while the bottom product, water, has a temperature of 103 degrees Celsius and pressure of 120 kPa. Move on to the design methodology of this column. Several major calculations are discussed which include the minimum and actual number of stages, minimum and actual reflux ratio, feed inlet tray location, column diameter, and column height. The minimum number of stages is determined under total reflux condition. It is determined using Fensky equation. For ideal mixture, Raoult's law and Dalton's law are applied in the calculation to determine the relative volatility. Before relative volatility is determined, K value is calculated using the vapor pressure determined from Antoine equation. With all these values, minimum number of stages calculated for this column is 12 stages. Besides, minimum reflux ratio for the separation of multi-component of this column is calculated using Underwood equation. To determine the root of the equation, Q value is calculated using all the value obtained from ICON simulation. Then the Q value is substituted into the equation to determine the root of the equation through iteration. With the root of the equation, it is substituted into Underwood equation and minimum reflux ratio calculated is 2.42. With the minimum reflux ratio, actual reflux ratio is calculated by assuming the actual reflux ratio to be 1.5 times of the minimum reflux ratio. The actual reflux ratio is 3.63. Next, actual number of stages can be determined using the ratio of minimum number of stages to actual number of stages, determined through Urbaugh-Mardox relationship. The actual number of stages calculated is 18 stages. However, in practical, n is the theoretical number of stages. The actual number of tray is calculated with the consideration of the tray efficiency determined using O'Connell correlation. The tray efficiency is about 43.6%, and the actual number of stages are 41 trays. In addition, feed inlet location is also calculated using Kilbride equation. Feed tray is located 16 trays from the stripping section, while 25 trays from the rectifying section of this column. Besides, several assumptions are made to calculate the column diameter. The assumptions are additional 15% of excess space is designed for the column. The tray spacing used is 0.45 meter. The maximum allowable flow rate is assumed to be 80% of the flooding velocity. And lastly, the downcomer area is 88% of the active area. With this assumption, the cross-sectional area of the column is 1.3282 meters squared. With the cross-sectional area of the column diameter calculated is 1.3003 meter. Next, column height is calculated with the similar assumption made to calculated column diameter. The total column height is 21.98 meter. With all the major calculation of the column, this is the specification sheet that includes the operating data and internal condition of the column. The operating data consists of column diameter, column height, tray spacing, and number of trays that are calculated as shown in design methodology. For internal conditions, All data of the inlet, vapor, and liquid stream are obtained from the icon simulation for this distillation column C105. With the design methodology, this is the equipment drawing of the distillation column C105 drop using AutoCAD. The total purchase cost, which include the empty shelf and sieve tray of the columns, are calculated. The purchase cost of equipment reference to the year 2019 is about 900,000 ringgit Malaysia. With this, I conclude my presentation on the major equipment design. Thank you.